Let's move to the next one. So we have to find the number of generators of the additive group Z36. So we have been given that the group G is Z36. The number of generators we have to find. The Zn is equal to what? Pi n. Number of generators given by pi of n. From there we can say that it has 12 generators. Okay. Let's move to the next one. So if we have been given that u is equal to x square minus y square is a real part of the analytic function fz, then the analytic function fz is given by z plus c, right? And you have that zeros of cos z are plus minus 2n minus 1 pi by 2. Now, if f is entire and bounded for all values of z in the complex plane, then you have to show that fz is constant throughout the plane. And finally, you have to find the value of this, right? Okay, let's try this. So if you look into the A, we have cos z is equal to 0. That means what number of zeros is going to be what? 2n minus 1 pi by 2, right? Now, f is an entire and bounded function for all z in the complex plane. So f is entire and it's bounded. So by Liouville's theorem, we can say that fz has to be constant throughout the plane, right? Now we have integration c2z plus 1 over z into z plus 1 dz is equal to pi I. So we have mod z is equal to half, z equal to 0 comma minus 1. These are the poles. Now z equal to minus 1 lies outside the circle. So integration c 2z plus 1 over z into z plus 1 dz. So from there, we can say that our option A is going to be correct. Okay, now we have to find the value of this integration. This is an improper kind of integration, right? Because we are having one of the limits as infinity. Okay, so we have integration 0 to infinity to the power minus x squared dx. Now, if we take x squared to be t, we have 2x dx is equal to dt. So our dx has to be replaced by dt over 2x. Now, if x squared is equal to t, we can simply say that our x is going to be root t. So we have to replace this by dt over 2 root t. Now I is equal to integration 0 to infinity to the power minus x squared dx. So this is going to be the function. Now we know the gamma function. So with the help of the gamma function, we can simply solve it. Great. Let's move to the next one. So suppose you have been given a position vector x I cap plus y j cap plus z cap, and the norm of this vector is given by this. Then we have been given gradient phi. You have to calculate, right? Okay, let's try it. Now the vector they have given us is xi cap plus yj cap plus z cap. The modulus of r is given by root over x square plus y square plus z square. The phi is what? Ln of r. Then grad phi is what? Gradient of ln phi. That is summation del x of this. Solving it, we get this, and hence our grad phi is this particular function. Now we have to find the area of the region bounded by the curves y equal to e to the power x and x equal to 1 in the first quadrant, right? So we have to simply use the integration formulas. So here we have that we have been given this curve and we have to given this one. We have to find the area between them, right? So this is our base. From here we are moving up. So we have 0 to 1 e to the power x dx e to the power 1 minus e to the power 0. So the area is given by e minus 1 units. Okay, so which one among the following are the integrating factors of the differential? The differential equation has been given. We have to find which one is the integrating factor, right? Okay, so if you look into here, this is a homogeneous kind of differential equation. So we have, and this is not exact, right? So 1 by mx plus ny is given by this. So from there, we can have this is going to be a integrating factor. Again, if we use this part, we can say that x and 3x are also integrating factor. So from there, we can say that we can get these two as the integrating factors, right? Now here have been given hx to be 1 plus x, gx to be 1 plus x to the power half, fx to be 1 minus x, and kx to be 1 minus x to the power half. So we have to match the lists, right? So how we can solve it? Let's see. So we haven't given hx to be 1 plus x. Then we have k of f is given by this function. If you calculate g of h, it is given by this function. If you calculate g of f, it is given by this, and h of g is given by this. So from there, we can say that option C is going to be our correct option. Now we have been given that for analytic function fz on domain, which of the following is correct? The real part is constant, then fz has to be a constant function. If modulus of fz is non-zero constant in D, then fz is constant in D. If f dash z is equal to 0 everywhere in D, then fz is a constant in D. If modulus of fz is a non-zero constant in B, then fz is constant for some value of z. We have to calculate all these. Okay, so we have that suppose fz is constant, we have to consider the CR equations. The CR equations are what? These are the necessary and sufficient condition for a function to be analytic. And the CR equation are given by this, where u is the real part and v is the imaginary part. So real part is given to be a constant. The partial derivative with respect to x and y are both zero, right? This implies that the partial derivative of v with respect to x and y are also zero. Therefore, we can say that the CR equations are satisfied for all points in the domain of fz, which means that fz is going to be analytic, right? Now, if we have the modulus is constant, then we root over u square plus v square equal to k. So from there, we can say that the CR equations, with the help of this, we get this to be the particular answer, right? From there, if we talk about the problem 57, they have given the subset to be this, and which of these are following correct? Is it a linearly independent? Is it a linearly dependent? How many vectors are linearly dependent, and so on. So we have to classify them. Okay, so if we talk about the set they have given, we simply check whether it's linearly independent or not. So from there, we can say it's a linearly dependent set. Now, since we are talking about the R cube, so in R cube, we can only have maximum 3 linearly independent sets. So since we are talking about the set which contains 5 elements, 5 vectors, it is obviously going to be linearly dependent. Okay, so option C is going to be our correct option.